Welcome everybody. Hi, Julia, Ryan, Abby, Sarah, Jared, Sam. Thank you guys for making it today, and thank you for taking your seats. Okay, we're going to get right into it. I want all eyes up here on the whiteboard. I see your eyes. We have a word here, a really easy word. On the count of 3, we're going to all say it together. You ready? 1, 2, 3. Light. So good. Okay, what I want you to do right off the bat is I want you to turn and talk to a partner. So you guys have each other, Abby and Sarah, you can be together. Jared and Sam, you can be together. And I'm going to give you just 1 minute. And I want you to turn and talk to each other and come up with one thing that you know about light. It can be anything. It can be from science class. It can be from at home, things you've learned before. Just one property or one thing that comes to mind about light. And then I'm going to ask each of you to share that one thing with me. Okay? Go ahead. Talk about what you do. Just talk back and forth, and then you guys can figure out, each of you figure out one thing you're going to contribute to my web diagram up here.
Let's say that it reflects.
Yeah. You're thinking nice here. You guys talking a lot. You got some good ideas. Abby, how you doing? Good. You each have one thing, and if we end up doubling up, that's okay. What I'll do is I'll put the idea up on our web diagram, and I'll just put a little tally mark or check mark. So if somebody steals your idea, it's okay. Try to think of a new one. If you can't, we'll just add it onto our list. Okay, you got about 10 seconds. Come up with just that one thing. And then I'll ask you, hold on to that thought. 3, 2, 1, done. Okay, so what I'm going to do is I'm going to call names out of my calling cup. We love this, don't we? Make sure everybody has a chance to share. Okay, I have picked Sarah. Can you give me one thing that you know about light? Ah, very good. Sarah said, I'm going to use a different color. She said colors. Light can be in different colors, right? So this is going to be part of our, we're going to be making kind of a spider web diagram up here, all about light. Okay? Ryan, do you have one thing about light?
It can reflect off of things.
Ooh, I love that word, reflect. Yes, and we've learned about that, haven't we? Light can reflect. Very good. Looks like we have Abby. What else do you know about light? Good, it's a form of energy. We've learned about that, haven't we? Energy. Good. All right, we've got Sam, what do you think? One idea about light. Excellent. We've talked about that too. Waves. Light travels in waves. We've talked about that as well. You guys remember a lot of great stuff. Julia.
It refracts as well.
Excellent. Another great word, it refracts, okay? We've learned about that. What's the difference between reflect and refracts, Julia? Do you remember? What does it happen when light reflects?
It like bounces off in a different direction.
Good. And do you remember what happens when it refracts, when it enters into a medium? What does refract mean? It's another simple word for refract.
Kind of like spread it, like, right?
It can bend and it can spread, right? It changes direction. Instead of coming right back at you, it's going to move into something and change direction. Good. All right, one more. We've got Jared. One idea about light. Jared said it's very fast. And we've talked about this before. The speed of light, I don't know if you can remember, is a whopping 300 million meters per second. That's a speed we can't even comprehend, right? Excellent. Great, you guys, this is great. The reason why we're going over light is because what we're learning about today, the things we're learning about today, share the same properties that light does. And it may blow your mind a little bit, some of the stuff we're going to talk about. So the only difference is between the things we're going to learn about today and light is the wavelengths and the frequency of the waves. And now, we've talked about that before, but I want to go and do a little bit of review. I'm going to pull this one down. Okay, there were a lot of other things we could say about light. We could say, you could think electricity, you could think lightning, you could think of objects like flashlights, things like that. So you guys did a great job. Light can be, you can think of many different things when you think of light. So we're going to review wavelength and frequency. We've done this before, but let's review this. I'm going to draw two different waves up here. I'm going to call this one A. And A is going to go like this. Like that. And B is going to go like this. Okay. Now we're going to do our thumb pull. Remember how we did that? Up for yes, middle for not sure, down for no. Okay? So I'm going to say this. Okay? A has a shorter wavelength than B. Yes? I'm not sure or no. A has a shorter wavelength than B. What do you guys think? Is that a yes? I'm not sure or I don't know. Okay? Ryan says no. Woo.
Wait, shorter?
A has a shorter wavelength than B. What do you think, Julia?
Oh, yeah. No.
Okay, so Ryan says yes. We got a couple no's. Sam, Abby, Sarah. Julia says no. All right, let's take a look. Remember how we measure wavelength from either crest to crest or trough to trough? We've talked about that before, from here to here. That's a wavelength. These are the same. Okay, so if we did that up here, from top to top, here's our wavelength up here, or here it is down here. So now that you see this, this might help clarify it. And this is what's tricky about waves. It's sometimes the opposite of what you think. A has a longer wavelength than B. So the answer to that was no, right? A does not have a shorter wavelength, okay? And you can see that, Ryan, does that make sense? You see the wavelengths? See how that's shorter than that one? Okay. Now I'm going to ask one more question, another thumb pull. A has a higher frequency than B. Yes, I don't know, not sure. A has a higher frequency than B. Think about it. Okay, Jared has it, Sam. Okay, both of you know that is correct. Okay, B has the higher frequency, and frequency is how many times the waves pass by a given point every second. So you see how fast this one is going? That frequency is going to be higher, all right, than this one. It's a long wavelength, okay? So what might be helpful is long equals low. Long wavelength equals low frequency. So if you can remember those two, then the opposite is true. Short wavelength is high frequency. Does that make a little bit of sense? Well, we're going to go through that as we go throughout our lesson today. But I just want to review that for you guys. We've had it before, so that was a good review for you guys. Okay. Now, I think instead of me talking all about this, we're going to look at a few of our pictures on the table, and then we're going to watch a short video together that I think will help introduce and sort of summarize our subject for today. So, Ryan, why don't you flip all those pictures over for me? Jared, you can help. Sam can help. Julia, you can help too. Okay? Just take a look at them. These are really simple, but I want you to start making connections here with what we're working with today. Okay. Can somebody hold up the microwave? Go ahead, Ryan. You got it? Right? Does everybody agree? Yes? Thumbs up. That's the microwave. Good. Can somebody hold up the rainbow? Go ahead, Julie. You can go back and forth if you want. Or Ryan. Yes, we agree. That's the rainbow. Julia, why don't you find the x-rays? Should let Julia have turn, yes. Good. She's got the x-rays. Julia, how about the remote control? Good. Ryan, how about the television? Good. Thumbs up. We all agree. Julia, the sun. Beautiful sun, isn't it? Good. Ryan, the Hulk. Do you know who the Hulk is? Let's see if anybody can figure out by the end of the class why the Hulk is in this mix. Yes, there's the Hulk. We'll see if we can make the connection there. And the last one, Julie, what do you see?
Cell phone.
It's a cell phone. All right. The reason why these pictures are out here, guys, is because these all have something in common, and that's what we're going to learn about today. The sun, cell phones, televisions, the microwave, rainbows, x-rays, even the Hulk. Okay. All of these things have something in common. Okay. In order to learn about that, we're actually going to watch a short video. And while we watch it, I'm going to pause it a couple times, and we're going to start filling out our spirals for this morning. Okay. So I'm going to give you guys each a pencil. Okay, you see at the very top. Yes, Ryan, you have a question?
Could I get a drink of water?
You can get a quick drink of water. Come right back. Thank you, sir. Okay. At the top of your spiral, go ahead, buddy, and come back real quick. Julia, can you read for me what that says at the top? Right there.
Electromagnetic spectrum.
Electromagnetic spectrum, and that is the word for today's lesson. So I'm going to put it up here. Okay? Electromagnetic spectrum. And I'm going to let you guys copy down the definition. Okay? So right up here, Brian, as you're coming back in, can you read for me the definition of electromagnetic spectrum? Can you read it from there?
The range of wavelengths and frequencies of electromagnetic radiation.
Radiation. That's a mouthful. We're going to try to make sure we understand what all those words. We've talked about wavelengths and frequencies. We just reviewed it. And electromagnetic radiation is a bit of a new term. And the radiation is found on the spectrum. The spectrum just means a range of something. So you can go ahead and copy down this definition. And as we go through the video, you have a space at the bottom of your spiral. We are going to construct our own really simple electromagnetic spectrum. But I think this video, and you can keep copying it while we do the video, but I think the video will really help you understand. It's only about 3 or 4 minutes long. It'll help you understand a little bit more about the electromagnetic spectrum and that it's everywhere. And we use it and feel it every day. Are you ready? Okay. You hear that? What's that?
Something surrounds you,
Yep.
bombards you, some of which you can't see, touch, or even
What
feel
that is?
every
A
day,
boombox.
everywhere you go. It is odorless and tasteless,
You know
yet
what that
you use
is?
it and depend on it every hour of every day. Without it, the world you know could not exist. What
These
is
are
it?
all the things we found already on the
Electromagnetic
table.
radiation. These waves spread across a spectrum from very short gamma rays to X-rays, ultraviolet rays, visible light waves, even longer infrared waves, microwaves, to radio waves which can measure longer than a mountain range. This spectrum is the foundation of the information age and of our modern world.
Okay, so I'm going to pause real fast here. All of you, I want you to make a long rectangle on the bottom of your spiral, just like this. But we're going to kind of fill in our own electromagnetic spectrum. So let's see how that has on the screen. And inside of that box, you can make wavelengths going from long to short, like this. And you can see it right there in the video. So you can have long waves that start getting shorter and shorter and shorter and shorter and shorter, shorter, like that. And that shows wavelengths. The lengths are decreasing, right? But the frequencies are increasing. And that's what you have to try to keep in mind, the way those two are related. Okay? So let's see what we're going to add on to
Your
our...
radio.
Yep. Okay, so down here, now we're going to make 7 sections. So 1, 2, 3. The one in the middle will be kind of skinny. 4, 5. So go ahead and draw those lines. And right here, the slowest one, these are radio waves. And you guys can just draw that in there. Radio waves are there. I'm just going to kind of, you guys keep going. I'm just going to keep kind of playing the video.
Remote control.
Yep. Believe it or not, remote controls use infrared. All right, so that's what's here. Infrared waves are here in this part. Okay.
Text message, television, microwave up.
All right. Microwaves. There is literally a thing called a microwave, which is why we call those machines microwaves, because they use, what do they use? Right?
Electromagnetic radiation.
And the specific kind of radiation they use is, it's really easy. Microwaves. Microwaves use microwaves. It's an actual radiation on the spectrum.
Oven, even a doctor's x-ray. All depend.
Okay. So what I'm going to do here, and you guys can do this later if we have time. I won't have you do any coloring right now. But right in the middle, right here, is what's called the visible spectrum. So you can write that on top, or I'm just going to call it visible light. You can write it on the top or the bottom, but that's where our rainbow spreads out. And it's important to remember that red is on this side and violet's on that side, because that's why this is called infrared, below red. And the next one that they didn't talk about, but I'm going to put on here, is ultraviolet. That makes sense?
Mm-hmm.
The ultra means above or extra or bigger, better. So that makes sense. Ultraviolet is on this side of the visible light, infrared on this side. They talked about X-rays, so we're going to put X-rays here at the bottom. Awesome. And then the last one they briefly mentioned were gamma rays. All right, and these are very high frequency, high energy waves that are very dangerous to us. And that's where our Hulk comes into play. Do you remember the movies? He experienced gamma rays, radiation, and he was able to withstand it, right? That's the one that's really dangerous. And because remember what happened to Iron Man at the very end of the movies. When he experienced that kind of radiation, was his body able to handle it? It wasn't. Unfortunately, took his life there. Okay, a couple more minutes here. All right, so now what we're going to do is I'm going to collect these, or put them over here maybe for a second. I'm going to collect your spirals for now. So we're going to introduce, you're each going to be in a little bit, going to be broken up into your groups, and we're going to do this research project. We're going to do the first one together, okay? Can you open your textbooks to page 134, Ryan? There's a little like bookmark in there. Both of you, here, Julia, everybody can open their textbooks. And you've got something right there, okay? And we're going to just walk through it together. Right now we're going to do visible light. But each of you, you're each going to take another radiation on the spectrum. Like Jared and Sam will take infrared. And Abby and Sarah will take gamma rays. And then you're going to research that radiation, and then we won't finish that today, but tomorrow we're going to come together and share our research together. Okay, so we're going to go through a few minutes of letting you see what I want from you guys, and I have the very same questions you have right here that are on your paper. Okay, so we're just going to go through a few just so you get the sense. The type of electromagnetic radiation right now, we are working on visible light. So that's just what you would put on. When you work in your groups, you're going to put in whatever I assign you, okay? Definition of your electromagnetic radiation. You're going to have that in your book. Your textbook separates each radiation out into its own paragraph. Your book is going to give you that. Now, those of you that need to see the digital copy of your book, you can open your iPads, your laptops, and you can access this. I've even downloaded this sheet. Can I borrow yours from Julia? I've downloaded this sheet on the team, so if you want to do this digitally, you can do that. You can manipulate the text and write with your finger or your pen. Okay, those that like the hard copy can work from there, but your textbook is also accessible that way digitally, so you can do that. That's fine. Okay, and the definition would be in there. So, for example, definition of your EMR, which stands for electromagnetic radiation. For visible light, it's the part we can see, right? Something simple like that. That's the definition. But each paragraph, each radiation is going to have a definition. Wavelength range, that's easy. That's in your textbook. For visible light, it's 400 to 700 nanometers. And the guy in the video talked about nanometers, and you're going to find that. Draw a simple diagram and identify. So this is what I mean. All right, here's your spectrum. Mine is right here, visible light. That's all I want here is just tell us where on the spectrum your radiation is, okay? And then you've got a couple questions. I'm going to just put this down for a second. I'll put it back up if you need it in a minute. The next question is give me real world examples. Visible light, easy, like light bulbs, flashlights. Again, these are in your books, okay? Is the EMR or the electromagnetic radiation harmful to humans? If so, how? Visible light? No. All right. Unless you, well, I'm not even going to put that because that's part of infrared. No, visible light is not harmful to humans or we'd all be in trouble, right? Is it helpful to humans? This one, Ryan, what do you think? Is it helpful to humans, visible light?
Yes.
Yeah, because what does it help us do?
See colors.
Yes, it helps us see and makes the world beautiful. Something like that, right? One interesting fact, and I forgot to use my calling up. Sam, what's one interesting fact about visible light? That's good, okay? It's not the only light in existence, right? We just learned about there's others on the spectrum. Abby, will you have any questions about visible light? Okay, and you may not. So this is a section for if you have any questions. I'd be curious what they are, and maybe our classmates would be curious. And Sarah, ways you might use this electromagnetic radiation, which is going to be similar to up here. So let's think of some few more, like candles, floodlights. Something up here that might be different is like the sun would be an example, or lightning. But those would be different than uses. So that's how these two can be different. All right, do you guys have any questions? Does this make sense? Okay, this project. And I'm going to keep these up here. I'll keep this one up for now if it'll stay, so that you guys can reference what I've done and hang on to what you've got so you can reference what you've done. Now, you can use your textbook or you can use online sources. You can Google this. I will allow you to do that because there's so much information out there these days. So keep your textbooks open. Julia and Ryan, I'm going to assign you ultraviolet light, so you only need one page. You can put both your names at the top here. Well, actually, no, you can keep that because you're going to use that. So you guys would have ultraviolet light. So that's what you would put your both names on here, your date, and together you just will make one sheet together, Ryan. So you will help contribute as partners. You will find this information as you go, either in your textbook or online, and I'm going to be circulating. Okay, I'm going to be helping you if you have questions. If you need any kind of help at all, I'm going to be doing that for you. Okay, we're going to transition to the very end. Okay, you guys can hang on to those for a second. All right, you guys did a wonderful job. Real quick, we've got a couple minutes left. I do have an exit ticket for you that I want you to work on, but right before we do that, we are going to do a really quick review in unison of wavelengths, because this is what your exit ticket looks like. It's going to be really simple if you read. Now listen to this. I'm going to read it out to you. It simply says, here, I'm going to use my glasses for a second. Put the radiations in the correct blanks in the diagram below. Here are the radiations in order from lowest to highest frequencies. You see what I've done for you there? And I've literally written them out, and there's even one there for you. So it should be really simple if you just think and you read. It's all there for you. So before you start this, say this with me together. Repeat after me. The shorter the wavelength, the higher the frequency. Go ahead.
The shorter the wavelength, the higher the frequency.
Good. The longer the wavelength, the lower the frequency.
The longer the wavelength, the lower the frequency.
Okay, now I just want you real quick to finish it for me. The shorter the wavelength, the higher the frequency. The longer the wavelength, the
lower.
Good. All right, I think you guys got it. So here's your exit ticket. You've got a couple minutes to finish this up. Hang on to your projects. If you didn't have a chance to finish them today, we can start tomorrow morning right off with finishing them, and then we are going to share out together of what we each found out about our different radiations. So thank you guys very much. Finish up. When you're done, you can put your exit tickets in the bin, and you may go when the bell rings.